This is the video for section 1-2 on points, lines, and planes. This is our first video of the year, so welcome to geometry. We will be skipping section 1-1 and we'll come back to it later on in the year when I think the ideas make a little more sense. This section is about some of the building blocks of geometry. And in this section, we will talk about how to describe points, lines, rays, segments, and planes. We will describe how they are related. We will learn how to correctly draw them and correctly name them. In this section, we will cover two geometry standards, G.1 and G.1.1. Okay, first, a point is an exact location in space. You can think of it as the corner of a room or the corner of a book or some specific location in space. Now on paper, we usually draw that with a dot, okay, like the one drawn here. Okay, we label a point using a capital letter. It has to be a capital letter. Okay, so the way I would name this point is point P, and you have to write P, the letters P-O-I-N-T, point. Do not write a point above it. Okay, that'll make sense a little later. We often put things above letters to signify what they are. You do not do that for a point. You write out the word point. Okay, but a point is an exact location in space. A line is a one-dimensional object that has only length. Lines will continue forever in both directions, which is why there are arrows on both ends. Okay, a line is defined by 2 points and is named using any 2 points on that line, or by a lowercase cursive letter. Okay, so this line down here can be called line AB or line BA, okay? And above those letters you have a line with arrows on both ends, signifying it's a line and it goes on forever in both directions, okay? This line's also labeled using a lowercase cursive letter, so you can call it line L. Okay, now just to kind of be super clear, if there's a point on here called point C, I could also call this line AC, again with a line with 2 arrows. I could call it CB. Okay, all these would refer to the exact same line, the line that contains those 2 points. Okay, now collinear points are points that lie on the same line. Okay, so down here I have a picture, and in this picture, points A, B, C, and D are collinear points because they lie on the same line, or they can be drawn on the same line. Points A, C, and E are non-collinear. They're not collinear because they cannot be drawn on the same line. A ray is a one-dimensional object that has a starting point but no ending point. So it's kind of like part of a line. Okay? A ray is also defined by 2 points and is named using the end point and then any point on the ray. So as you name a ray, this very first letter, this left letter, has to be the end point. Okay? And then the second letter is any point on the ray. And above those 2 letters, you have, again, a line that is always pointing to the right. Okay, to give you another example, if there's a point right here called point C, I could label this ray either AB, like I have example over on the right, or I could call it AC. They're the exact same ray because I have the endpoint A and then a point that's on the ray. Okay, again, the arrow always points to the right. Opposite rays are 2 rays that share the same endpoint and are going in opposite directions, so they form a line. Okay, so here I have a line with 3 points on it, and on here I can identify some opposite rays. Okay, first of all, the ray that starts at C and goes in the direction of A, the way I label that is by saying the endpoint, then a point on the ray pointing to the right, and the ray starting at C and going in the direction of B would again be labeled C, the endpoint, and then the direction is B. So the opposite rays are CA and CB. You label them just like you do a ray. Next, a line segment, a one-dimensional object that has a starting point and an ending point. Okay? Sometimes they're called simply segments by themselves. Okay? Line segments can be measured. If you have a ruler or some kind of a metric, they can be measured because they start and they stop. Okay? A line segment is defined by 2 points and is named using the 2 endpoints in either order. So this segment down here can be called AB or segment BA. Notice that there's no arrows on this line above it because it does not go on forever in either direction. It has a starting point and an ending point. Next, how lines are related. Now, lines can intersect, they can be parallel, they can be perpendicular if they intersect, meaning they intersect at 90 degrees. We'll talk a lot more about that this year. Okay? And there's one more option. Okay? And that fourth option are called skew lines. Okay? Skew lines are 2 lines that are not parallel but don't intersect. Okay? They only happen in 3 dimensions. Okay? Because in 2 dimensions, they either intersect or they're parallel. Okay? But in 3 dimensions, you can have 2 lines that are not parallel, but they miss each other. They don't intersect. Okay? So here are 2 examples down here of skew lines. Next, a plane. Planes are 2-dimensional flat objects that go on forever in all directions. Okay? A plane is defined by 3 points and can be named using any 3 non-collinear points in the plane. So you pick 3 points in the plane and you define it using those 3 points, but those points cannot be collinear. Okay? Or sometimes planes are named with an uppercase cursive letter. Okay, in this case, P is not a point, it's the name of the plane. So you can call it plane P. Okay, or you can use 3 non-collinear points in the plane. Now, points and lines that lie in the same plane are called coplanar. Similar to collinear, they're coplanar. Okay, so in this example, points E, G, H, and line FJ are all coplanar. They lie in the same plane. But line L, you can see it's kind of coming up, out, and then going down into the plane. Line L is not on plane EFH. Okay, so they're non-coplanar. Planes can intersect, they can be parallel, and if they intersect, they can be perpendicular if they intersect at 90 degrees. Okay, there's no third option. Planes can't be skew because if they're not parallel, they will intersect somewhere. Okay, a postulate or an axiom. This is the last idea in this section. Okay, a postulate is an accepted statement or fact. Okay, later this year, we will talk about proving that statements are true. Okay, a postulate, on the other hand, is accepted as true and doesn't require a proof. Okay, it's just accepted to be true, and that's what a postulate is. Here are a few examples of postulates. These do not need to go in your notes. Okay, I just want you to be exposed with some postulates. Okay, postulate 1-1 states, through any 2 points, there's exactly 1 line. Okay, that's just accepted to be true, that if I take any 2 points, I can draw a line through them. Okay, postulate 1-2, if 2 distinct lines intersect, then they intersect at exactly 1 point. Okay, that doesn't need to be proven, it's accepted to be true, that if 2 lines intersect, they are straight, and so they can't intersect somewhere else. Okay, postulate 1-3, if 2 distinct planes intersect, then they intersect in exactly one line. So if there's two planes that intersect, they will intersect at exactly one line. That is accepted to be true without requiring a proof or a logical justification for why it's true. Okay, this section was about points, lines, and planes, some of the building blocks of geometry. Hopefully you can now describe how they are related. You can correctly draw these building blocks and also correctly name them. Thank you.